Compass makes extensive use of calculations involving the time in therapeutic range, which is abbreviated TTR. TTR. There are different ways of calculating TTR. The method that is used in Compass is the classical method described and published by Dr. Rosendahl. Reference to the methodology of this is listed on the title page of this video. It's easy to understand the concept of TTR, although the calculation itself is difficult and basically requires computer systems to calculate accurately. But I think we can demonstrate the concept, and I think that once a user understands the concept, its value becomes apparent. So I have 3 patients listed. These are all test patients. The first is 1 ZZZ Rose. We're going to open her chart. We're going to look at the summary of all of her coagulation graphics. And you can see that in this case, over the course of a year, her INR was 2.5 at the beginning of the year, 2.5 at the end of the year. There are only 2 INR, for simplicity, there are only 2 INR values included. And you can see in the bottom graph is the TTR calculated over 365 days, 1 year. And she was 100% in the TTR calculation because all showing at 2 INRs, and both of them were in therapeutic range. All right. The second patient is 2 ZZZ Rose. And the coagulation statistics for this patient are different. Again, only 2 INRs were recorded for simplicity, 1 year apart, both of which were high. And as a result of that, the TTR, the time in therapeutic range, was 0. There was never a time in the past 365 days when the patient had a therapeutic INR. So the final demonstration is 3 ZZZ rows. And this patient also had 2 INRs. The first was high at 4 a year ago, and the second was low at 1. So again, just like the previous 2 examples, none of the INRs are within therapeutic range. However, if you look at the TTR escalates over time. The reason for that is because the final TTR calculation is 33%. So a third of the time, the program is calculating that the INR was within therapeutic range. How is that possible? Well, if you draw a line between here and here, it will hit the therapeutic range 1/3 of its distance. So the program is calculating that 1/3 of the days in the past year, the patient was within a therapeutic range from this date to this date. And then when the INR was low or the INR was high above those dates. So the TTR for this patient is actually 33%. So you can appreciate that the mathematics of this can become quite complicated. Let's use another example. So here's a complex patient. And in this case, the patient's date extends back farther than a year. When we're doing TTR calculations, we are only looking at the past 365 days. Now there are other TTR values, but it's actually a rolling calculation. Every time an INR is entered, we look backwards 365 days. We use the Rosendahl method to calculate the TTR for the previous 365 days. In this case, you can see we have a lot of INR values in here, many of which are high. This last one is low. The last two are high. And as a result of that, the trend of TTRs is increasing during this time because all of these values from here to the left are within therapeutic range. But as soon as we start getting into these high sporadic values, the TTR begins to plummet. And we end up with a fairly low TTR at 18.5%. So what that's saying is that in the past year, from this point to this point, that the number of days that the patient was in therapeutic range from here to here was only 18.5%. So how is this useful? Well, the TTR is the gold standard of effectiveness of anticoagulation. A patient may be very high one day and very low the next, but as long as most of the days that the patient is being monitored are within therapeutic range, then the risk of embolic events is low and the risk of bleeding events is low. The TTR calculations in COMPASS are calculated instantaneously with each INR entry. So whenever we add a new INR, the TTR for that patient is recalculated and is updated to the current date. TTR has another benefit. The TTR allows us to calculate the general statistics for a given coagulation clinic. So in this case, we're in the CHUK clinic. We're going to look at only test patients. And you see these sporadic lines. Each of these lines represents the TTR for a single patient enrolled in the CHUK clinic. And because these lines are so sporadic, you might think that this is not much value. It probably is not. But in real practice, patients will tend to fall into two groups. There'll be those patients that have well-controlled INR numbers, and their TTRs will typically run 70 to 80%. There will be another group of patients who are difficult to control for a variety of reasons, maybe compliance, maybe medications, maybe diet, maybe lack of follow-up. And those patients might tend towards lower TTR values and will be grouped here at the bottom. So it's a way for us to identify within one clinic, it's a way for us to identify those patients that are having problems and those patients that are in good control. Final use of TTR is for the comparison from one time period to the next. So it might be that COMPASS is beneficial in improving the TTR of its patient population. We can calculate that statistically by comparing the TTR in last year versus the TTR of the same group of patients this year, and determine whether or not the COMPASS program has been a benefit. Under reports, there are pre-constructed reports that help in evaluating TTR and extracting the data, if you wish to do so. TTR data. In this case, we're going to take all charts seen by all clinics, all providers. And this is what that report looks like. For each patient, there is the last INR, last warfarin dose, the last TER. This isn't the only TER, it's just the last one for the patient. And finally, there are the TTR trends. As I mentioned earlier, every time an INR is entered, the TTR is recalculated for the previous 12 months. So this is a running list, a running average of the data for this patient. In this case, in September 22, patient had an INR 0, had a TDR of 0 with a INR 1.9 and a warfarin dose of 35. This data can be extracted. Simply use pipe or comma. You can select all, copy, and then paste that into Excel for import into Excel statistical programs or other statistical programs.